All right, so the last part of this set of notes, we have to focus on writing equations. So we're going to talk about slope. Slope is the change, sort of like the slant of the line, or the change in y over the change in x. This is the formula to calculate slope right here, given two coordinates, and there's some important things about slope. Vertical lines have undefined slope because they're up and down. Okay, and I guess no slope is not the same as zero slope, so just keep that in mind. I would prefer you to just keep it as undefined slope. For horizontal lines, those have zero slope, so zero meaning the number, because there's no slant to it. Parallel lines have the same slope, and perpendicular have slopes that are opposite reciprocals of each other. So let's try a few of these. So again, it notes point slope form. Don't worry about point slope form. We are focusing only on the y equals mx plus b. That is what I stress, and that's what we'll be using. All right, so we're going to write an equation in slope-intercept form for the line that has a slope of -3/2 and it passes through -4, 1. So we're putting it in y equals mx plus b. According to what we have, this is our m, and if we have a point, that is our x and that is our y. So when you write an equation, you need m and b accounted for. So far we have m, so we have to get b. So we're going to sub everything in. So 1 equals -3/2 times -4 plus b. So when we multiply, we get 12 over 2, which is 6. So 1 equals 6 plus b, so b is -5. And when we write the equation, don't forget to actually finish the problem and write it. Y equals -3/2 x minus 5. Again, m and b need to have a value in its place. The difference with 7 is you're given 2 points, so we're not given the slope, which means we have to calculate the slope first. So let's label x1, y1, x2, y2. We're going to slub it into our formula for slope, which says y2 minus y1, x2 minus x1. We got the double negative in there, so be careful. And you get 1 over -3. So now we have the formula y equals mx plus b, and we've got our -1/3 to plug in so far. Now the next piece we have to find is our b. Well, we have 2 points to work with. It doesn't matter which point you pick because they're both on the line. So let's just say I'm going to go with -1/4. So 4 equals -1/3 times -1 plus b. When I simplify, it's a positive 1/3 now. And then you ask yourself, okay, well, how many thirds make 4? Well, that would be 12, because 12 divided by 3 is 4. So then 12 thirds minus 1/3 is 11 thirds, which gives you your b value. So we now have y equals -1/3 x plus 11 thirds for that problem. All right, last part we have to go over is just graphing an inequality. So when you graph an inequality, this is where the shading component comes in. Before anything occurs, though, it needs to be in y equals mx plus b. So, for example 8, we got to get it in that form. So we're going to move the x to the other side, and then we're going to divide everything by -2. But now thinking back to our algebra days, when you divide anything by -2, the sign flips. So this becomes 1/2 x, and this becomes a -2. All right, so when you divide by a negative, it flips. So before we actually sketch this, a couple things we have to keep in mind. It's greater than, not greater than, equal to, so this is a dashed line. Our slope is 1/2, and our y-intercept is -2. So when we sketch this, we start at -2, and we're going to move up 1 over 2, up 1 over 2. But you only need 2 points to make a line, and just remember, when you make your line, it has to be dashed with arrows on the end. So now what you do is you can test your values to determine where to shade. So let's just say we pick something above. Let's just say we pick 0, 0. So I'm going to pick the point 0, 0, and I'm going to plug it into the formula. So 0 minus 2 times 0 is less than 4. Well, 0 minus 0 is less than 4. 0 is less than 4. Is that a true statement? Yes, it is, which means if it is true, then that is where you are shading. So you're going to shade above. If you had picked something below that line, you would find out it's a false statement, which is also telling you that you have to shade above that line. Now, besides linear functions, you might have to graph an absolute value function. So when you graph an absolute value function, what you do is you set this equal to 0. And that's going to give you the x value that you start with, which would be equal to 2. So we're going to go over here, 1, 2, and make a dot. This is a solid line because it's greater than or equal to, and it's a V-shaped. So it's going to go like this. Now what you can do is, just like we did with the linear function, pick a point. So let's just say I'm going to pick the point 2, 2, and I'm going to plug it in. So 2 is greater than or equal to the absolute value of 2 minus 2. So 2 is greater than or equal to 0. Is 2 greater than or equal to 0? Yes, this is a true statement, which means I'm going to shade every